Today's date is May the 4th, which seems like an appropriate day to talk about a galaxy which is not so far away. We've talked about the Sun, the Moon, and Earth, but today we'll talk about the solar system and the planets. The Sun is the center of our solar system, which means that the planets orbit around it, and each planet has unique characteristics, which we'll talk about right now. But first, the planets are divided into two neighborhoods. The four inner planets near the Sun are called terrestrial. These planets include Mercury, Venus, Earth, and Mars. Just beyond this neighborhood is a belt of asteroids, which separates from the outer planets. These planets include Jupiter, Saturn, Uranus, and Neptune. These outer planets are called Jovian and are going to be larger than the inner planets, but less dense, because their composition is mostly of gases, which is less dense than solids. The first of the inner planets is Mercury, which is closest to the Sun, so its orbit takes the shortest amount of time. It has many craters similar to our Moon, since it has a weak gravity which prevents it from retaining an atmosphere that would protect it. We are given information about the planets on this chart called Solar System Data. First, we'll list the different celestial objects like the Sun, the planets, and Earth's moon, as well as some characteristics. First, let's look at this column, mean distance from the Sun, which means on average how far is this planet away from the Sun. As you can see, as you go down the list, the number is going to get higher, meaning you get farther away from the Sun. Let's look at Mercury. Period of revolution and rotation. Revolution means how fast does it go around the Sun, which will determine the year. Period of rotation means how fast does it spin on its axis, which will determine the length of a day. Mercury's year is going to be 88 days, and its day is going to be 59 Earth days. The next piece of information we're given is eccentricity of orbit. Refer back to our lesson last week when we talked about eccentricity. This means if the orbit is going to be more circular or more oval. And the last three we'll talk about the planet itself. Equatorial diameter means how wide is it at the equator, how big the planet actually is, mass and how much it weighs compared to Earth, and the density it's going to have. Venus is the second planet from the Sun, and it's called Earth's sister planet because they are near each other and have similar characteristics. Venus has volcanoes and tectonic movement just like Earth. In 1985, a weather instrument was put in the atmosphere near Venus, and it showed that Venus' atmosphere was made mostly of carbon and some nitrogen, and they act like greenhouse gases which trap heat, making the temperature on Venus very hot. Let's look at the chart for Venus. You will see that the period of revolution, how long a year is on Venus, is 224.7 days. The period of rotation, how long each day is longer than that. It's 243 days. Because the rotation is going to be slower than the orbit, this is going to mean that one day on Venus is longer than a year. We've talked about Earth in this class, and it's also on this chart. The period of revolution for Earth is 365.25 days. That's how long it takes to go around the Sun, which is the length of our year. And the period of rotation is just under 24 hours, which is the length of our day. Mars is the fourth planet from the Sun and the first outside Earth's orbit. It's similar to Earth since its axis is also on a tilt, which creates the 4 seasons that we have on Earth. But the orbit is longer than Earth, so the seasons are longer too, and it's also going to be farther, making the temperature on Mars colder than Earth. Let's see this information on the chart. For Mars, the period of revolution, how long it goes around the Sun, is 687 days, which is just under twice Earth. This is why the seasons are longer. However, this doesn't affect the rotation, how fast it spins, which is going to be a similar amount of time to Earth. Currently, liquid can't exist on the surface of Mars because it would quickly freeze. However, valleys and stream paths that were found on Mars indicate that Mars may have had a thick atmosphere with abundant liquid water on its surface. Was there ever liquid water on Mars? And could life have existed there in the past or now? This will be answered only with further exploration. After the 4 inner planets, we have the 4 outer planets that are called Jovian, and they all have ring systems, whether or not we show it to you right now. Jupiter is the biggest planet and 5th from the Sun. The Great Red Spot is the most striking feature of Jupiter's surface. Jupiter's period of revolution, meaning how long it goes around the Sun, is going to be almost 12 years, and its period of rotation, how long a day and night is going to be, is about 9 hours. Let's look at the planet itself. The diameter, how big the planet is going to be much larger than any of the inner planets, as well as its mass, how much it weighs. Saturn is the 6th planet, and least dense of them all. Its density is lower than that of water, so if it was in water, it would float. Let's see this on the chart. Saturn's period of revolution, how long it goes around the Sun, is going to be 29.5 Earth years. The period of rotation at the equator is only going to be 10 hours, however. Let's look at the planet itself. Its diameter is also going to be much larger than any of the inner planets. But let's look at the density. Water's density is 1. If you look at the density on the chart, it is less than 1. It's 0.7, which means that if it was in water, it would float. Uranus is the 7th planet from the Sun, making it colder and harder to see since the Sun's light is fainter. Its axis is sideways so that it orbits the Sun on its side, and as you can see, it's not going from side to side, rather it's spinning from up to down. Its period of revolution is going to be 84 years, and the reason why the outer planet's revolution keeps on getting longer and longer is because they're farther away from the Sun, so to complete an orbit they have to travel a lot more distance. But the period of rotation, is going to be pretty much the same. Neptune is the farthest of the Jovian planets from the Sun. It has very strong winds and is very cold. The period of revolution is also going to be much longer, 164.8 years, but its day is going to be 16 hours. And finally, the last row on this chart is Earth's moon. Earth's moon is not a planet, but it was included on this chart since they may ask you questions about this. We're given the distance from the Sun, which is 149.6 million kilometers, and we're also given the distance from Earth, which is 0.386 million kilometers. You may be thinking that there's a planet missing from this list. Pluto. Pluto is smaller than Earth's moon. However, the reason why it was considered a planet is that its peculiar orbit will occasionally bring it closer to the Sun than Neptune, making it the 8th planet in the list. However, in 2006, Pluto was reclassified as a dwarf planet.
Dwarf planets are a lot like regular planets. They both have enough mass and gravity to be nearly round, unlike odd-shaped asteroids. They both travel through space in a path around the Sun. The big difference? A dwarf planet could be in for a bumpy ride as it travels. Its path is full of other objects like asteroids. A regular planet has a clear path around the Sun. Most of those impacts happened billions of years ago, so there's not much left over to get in the way. There may be dozens of dwarf planets in our solar system. So far, we've classified just a handful, most of them very far away. Pluto is the most famous, but closer to home is another mysterious world, Ceres, the first dwarf planet to be visited by a spacecraft. With everything we learned from the Dawn mission, our understanding of planets and dwarf planets will rocket far beyond all that's been known before.
That's all you need to know for today. Tomorrow we'll talk about solar system debris, rocks that float in space like moon, asteroids, and other things. Please make sure to answer the questions correctly in the form below. If you have any questions, you can send it to me in the Google Classroom and join me on Zoom. Thank you so much for watching. Have a great day.